The question goes like this. A pipe 20 centimeter long is closed at one end. Which harmonic mode of the pipe is resonantly excited by a 430 Hz source? Further, will the same source be in resonance with the pipe if both ends are open? Speed of the sound is given to be 340 meter per second. Alright, what is given? What you need to figure out. Okay, so two things are there, isn't it? So first let's write down what is given to you. You have velocity v to be 340 meter per second and you have the frequency f to be 430 Hertz. Correct? Now the first part of the question, try to understand, the first part of the question says which harmonic mode of the pipe is resonantly excited by 430 Hertz source. Correct? First is, it's a closed end. It's a closed pipe. Correct? And also, the length of the pipe is given. L is equal to 20 centimeter, right? So, 20 into 10 power minus 2 meter. Okay? For closed pipe, you have, you're going to have the frequency F is equal to 2n minus 1 into V divided by 4L. Now, you need the value of n, correct? Make n as the subject of formula. So, you are going to get f into 4L is equal to 2n minus 1 into V. Or, you are going to take the next value as 2n minus 1 is equal to 4f into L divided by V. Or, n is equal to, you will get 4L by V plus 1, the whole thing multiplied by half. This is going to be the value of n. Just substitute the value, that's it. So if you are going to substitute 4 into n is equal to 4 into 430 into 20 into 10 power minus 2 divided by 340 plus 1, the whole thing into half. Guys, the best way of solving this is by using a calculator. Okay, or if you are really good and fast, please quickly solve this one and see what value you are going to get. Alright, you are going to get 1.01. In the sense, which harmonic mode? 1.01 is 1. So, the first harmonic mode. So, the answer for the first question, which is for the closed at one end, the closed pipe. Which harmonic mode of the pipe is resonantly excited? It's the first harmonic mode. Okay, now if you try to do the same thing for the next one, let's try to do the same thing for the second part of the question. What you get is F is equal to NV by 2L, isn't it? So, again you need the value of N. So, N is equal to 2F into L divided by V, which gives us 2 into 430 into 20 into 10 to the power of minus 2 divided by 340, which gives you 0.51. Now, think about it. We have a value of n less than 1. Can you have a value less n of, the value of n less than 1? Impossible, correct? In the sense, there is no position for which you are going to have a resonance here. So, for a closed pipe, it is the first one. For an open pipe, there is no position where you are going to have resonance. Alright? So, these are the answers. That means you have to write it down. Therefore, no position in open pipe gives resonance. It's a very, very important conclusion. Alright? This is how you need to solve this particular question. Now let's do the next one. The question goes like this. A wire stretched between two rigid supports vibrates in its fundamental node with the frequency of 45 Hz. The mass of the wire is given with its linear mass density, that's also given. What is the speed of the transverse wave on the string? The tension in the string. Again, don't you think this is a particular question based on the previous formula? As in V is equal to root of T by M. Again, before that, let's write down what is given to you. Alright. See the first one, frequency. You have F1, fundamental frequency is 45 Hertz. Then mass is given to be 3.5 into 10 power minus 2 kg. Fortunately, they have already given mass per unit length. So m is equal to 4 into 10 power minus 2 kg per meter. Okay. They are asking you what is the speed of the transverse wave on the string, the tension in the string. So these are the two things. Now remember, for the speed we need v is equal to root of t divided by m. Correct? We don't know t, but of course we know m. But look at the second part. The second part is they are asking you this tension in the string. Correct? That means there has to be another way of trying to figure out how do we get the value of the tension, or we also have to understand how do we get the velocity, either one of them. Correct? This is how this particular problem has to be approached. Now let's try to solve this one now. To approach this one, see, we can use another formula that is v is equal to f lambda. Correct? Or we can also use another one, that is, see, we can calculate the length. How? Using mass per unit length. See, what do we have? Mass per unit length, m is equal to m divided by L. So L is equal to capital M divided by small m. 3.5 into 10 power minus 2 by 4 into 10 power minus 2. 3.5 by 4, 30, 35 by 40. 35 by 40 becomes 7 divided by 8. Now, this 7 by 8 meter is the length, isn't it? Now, the next thing what we can do is we can calculate the value of lambda. Since it is between two rigid supports, see, what we know is that whatever you have to calculate one lambda will be equal to 2L, because coming back, correct? Lambda is equal to 2L. Now, L value is 7 by 8. Lambda is equal to 2 into 7 by 8, which is 7 by 4 meter. Once you know the value of lambda, you can calculate velocity. That means we can answer the first question, v is equal to f into lambda. Now, the frequency is given to be 45. So, 45 into 7 divided by 4. Okay, this becomes the velocity. So, you are going to get 78.75 meter per second. This becomes the velocity. Now, we have the tension. So, for tension, v is equal to root of t by m. Okay, let's apply this one. Let's try to calculate this one. V is equal to root of t divided by m. So, you have t is equal to v square into m. Correct? What is the velocity? 78.75 square into 4 into 10 to the power minus 2. Correct? Now, once you solve this one, you are going to get the tension. The final answer becomes 248.06 Newton. So, the answer or the tension in this particular string is going to be this much. Understood? The velocity is 78.75, where we calculated with the help of lambda, and with the help of this velocity, we calculated the tension. Okay? There are a couple of more problems which I encourage you guys to go and solve by yourself. Okay? And also understand the concepts before you apply these concepts in the problems.